Okay, so today I'm just going to be doing a very short video on how to create a fading line like this. And the motivation behind this was sort of looking at very nice videos like this one from physics simulations showing the orbits of the planets around the sun. And then also the Rebound package makes some very nice plots. If you go to a Rebound, it's an N-body simulator. I'll put the link below. But they've got examples of visualizations of some simulations, and they have some very nice trails on all their objects. And I wanted to recreate that little snippet of code that I could use in some other projects. So I'm going to show you some of the code that I've modified from Rebound to create this little plot, and how maybe you can use it in your work. Okay, so the first thing we'll need NumPy, Matplotlib, and then a specific function from Matplotlib collections, the line collection. So I just, in fact, I'll go back, show you how we're going to do this. So this line that's currently faded is actually lots of little segments broken up. So it's broken up into segments. Each one has a different value for alpha, value for transparency, and that's all stored in a line collection. Okay, so I'm just going to copy across some code which will generate that nice circular line for me. So here I'm just generating a circle with radius 1 through 0 to 2 pi. So nice circular line like you saw in that example. Okay, now I'm going to define a color and a initial transparency for the line. So I want the alpha to be 1 at the very start of the line where the object is, and then the color, this is just an RGB value for a nice green that you saw on the plot, so I'm going to use those. And then I'm going to start the function, so we're going to start the fade line function. Okay, so we're going to start our function, call it fade line. It's going to take the x position, x points of the line, y points of the line, the color of the line, and the initial transparency of the end of the line. And then we want to know how many points are in this line, because it's going to grow. Well, it could grow. I'll show you an example of it growing later. And then we're going to create some color arrays. So we're going to create colors. Let's use numpy.zeros. And then the number of points times by 4, and that's because we're going to define the colors as RGBA, so red, green, blue, alpha, and 1 for each of the points that we're using. So let's just take colors, colors, and then the first 3 columns RGB are just going to be our color. There we go, and then colors, our 4th column, our transparency. We're going to use numpy.linspace to generate for us, so is equal to our original alpha. So we could fade the whole line out if we wanted to with this alpha, and then numpy.linspace 0, 1, and the number of points. There we go. Okay, so now we're going to generate segments. So I said that that line was segments of a full line, and each segment had a different alpha value, which we just generated using colors. So let me start by typing segments, and that is going to be numpy.zeros for the moment, and endpoints -1 to 2. So 2 is just the x and y positions of the start and end of the segment, and then num points -1 is because we have the number of points -1 number of segments for our line of n points. So you've got n points, n-1 segments making up that line. Okay, so we're going to extract the start values and the end values for the segments. So I'm just going to do segments, and then we'll take this slice 0, and the same for Y. Okay, so these are the segment start values. So I'm slicing off the last value, so I don't need it. So those are the segment start values, and then I'm going to do the segment end values. So now I'm choosing the end values, going to use that index, and then I'm going to slice off the first number, because that won't be used for an end value. So these are the end coordinates for each segment, and I want 1, 1, and that's going to be equal to Y, and again slice off the first value. So lines 22 and 23 are the start values of all the segments, X and Y values of all the segments, and then 24 and 25 are the end X and Y values for all the segments. So now we have our segments all together. We can make a line collection with those segments. So LC is our line collection of our segments. Using color is colors, so using our colors, and then our function is just going to return our line collection, and that's it. So what I'll do now is I'll just copy across some code that you can see it plotting nicely. So I'm just going to go across. Okay, so I've just added some plotting code at the bottom, and if I run Python fade, I didn't save it. Now if I run Python fade, there we go. So it's constructed our circular line out of hundreds of little line segments, each with different alpha values of the same color. So I wanted to make this because then if I show you a slightly more complicated example, if I run Python n-body, so if we did an n-body simulation like rebound, or maybe not something a bit simpler, but where I wanted a trail of where the particle or planet, whatever, has been before, we can show the trail as a fading line. So here we've got some particles interacting. This isn't rebound, it's similar to rebound, and you can actually see here as this green line is starting to extend that it's made out of those little segments. You can just about see the discontinuity between them. Okay, anyway, I've put this code on GitHub here in snippets because it's a tiny piece of code. I hope you find it useful. I will certainly be using it in a lot of projects moving forward.